Okay, we'll take a look, and today I will introduce just a little bit of SQL or SQL, structured query language, and that's what we'll take a look at. And there's a lot you can say. We'll start with the basics, and we'll kind of go from there. So. Number one, don't try to set up your own SQL server. So don't go out there and download MySQL, or you can do this, but that's not what this is about. So there's a big difference between, say, setting up and running a SQL server and learning how to write a few queries. We're going to learn how to write a few queries. We will not learn how to set up a server or design a database or something. If you go and work and it says you need to know SQL, probably they're just talking about somebody who's able to write queries, as in just retrieving data from a database or server that already exists. There will probably already be a person who has set up and has designed and maintains the server, and that's going to be a separate job. That's database administrator. You can take an entire course on kind of database structure, database design, and things like that. We're not going to cover that, okay? And so what we are going to kind of mess around with is we're going to use SQLite, and there's going to be a database that we can kind of practice with, a practice database that allows us to write queries so we can kind of get the results back. Okay. There's a few more. There's a couple resources online that I've linked to. One is this set of Sql Exercises. And you can just kind of start here, retrieve data from tables. Sorry, there's a bunch of ads and stuff. And it says, write a SQL statement to display all the information of all salesmen. And then you go to the editor, and the answer is going to be something like select star from, what's the table? Salesman. Okay, so it's going to just be select star from salesman, and that will be the answer. Okay, and then you can kind of click submit, and you can get your results, and you'll say, oh, okay, it seems like that's working. Okay, and all of these things, they have a little solution that shows you, what they're expecting and what kind of code you should write. And I think this is a pretty good website. Okay, there's another place where you can kind of mess around called Sql Fiddle, and you have to first build a schema. It's a little bit of work here. So what you might have to do is you'll take a CSV and you'll paste it here, and then and then you can import it. So it takes a little bit of work. You first have to kind of get your data into Sql Fiddle, and then you can start writing queries and things like that. What we're going to look at today is there is a database. It's called the Chinook Database, and Chinook, kind of like the helicopter, and I think it comes from a word meaning north wind. There's an old database called the Northwind database that was based off of. Okay. Anyway, we'll use a package called Sql Alchemy, or Sql Alchemy, that allows us to kind of connect to these databases via Python. Okay, so again, if you ever work somewhere, have an internship somewhere, they will probably give you instructions on how to connect to an existing SQL server database. Okay, they will give you that connection part, and then you'll be responsible for writing queries to download that stuff. Okay, and once again, we are not going to be the database administrator. We're just going to do this. Okay, so anyway, you'll come over here to this data sources, and there's a bunch of different things, but you're going to download the SQLite file. Okay, the Chinook _SQLite. This is the file that you will download. So it's basically the Chinook database in different types of SQL, and we'll just use the one for SQLite. There's a bunch of different kind of versions of SQL, and they're very similar. Some of them have a few features that others don't, but for the most part, as far as writing queries and getting results back, there's a lot of similarities. All right, so we will import pandas and Sql Alchemy, and from Sql Alchemy we will import create engine. Okay, so this is, I think, already installed on your system when you install Anaconda. If not, you can always do conda install SQL Alchemy if you get some kind of error here. Okay, and I have already downloaded Chinook _SQLite.SQLite. This exists in my folder. I've uploaded it to GitHub as well, and so if you if you pull the changes from GitHub, then these things will download. Okay, and to connect, as far as SQL Alchemy goes, is we're going to create a connection, and we call this an engine. We create an engine, and this is what we have here. Okay, so anyway, this is how we would create the SQLite connection. You basically just give it the name of the database again. And again, depending on what company you work for, they will have instructions as far as getting this connection going. And so this part will look different for everybody. And again, it's kind of a pain setting up your own database. So there aren't too many example databases out there. I was trying to search. This is probably the most commonly used one. Okay, and you can kind of just make sure that you've connected. And so we're going to import the inspector, and we'll just do inspect the engine, and we call this thing INSP, the inspector, and we'll do inspector.getTableNames, and it gets the names, the table names of the Chinook database. And so this, I don't know if you remember, but maybe 15 to 20 years ago, you could go, because I think for music, everybody uses kind of like Spotify or these different streaming services like Apple Music or something like that. But 15 years ago, you could buy individual like MP3 files. I don't know if you ever remember doing such a thing. And so this database was kind of made during that time, and so it has fictional customers who have created orders, and each order or an invoice is basically like they ordered this song and another song, and you would purchase individual songs for like 99 cents. I don't even know, is that even possible? Can you still do that somewhere if you wanted to, like on iTunes maybe? Okay, maybe like $1.29 or something. So it's kind of like this idea where you could buy individual tracks and something. And so there's a bunch of information. There's like there's a table of tracks, okay, and the tracks belong to albums. The albums belong to artists, okay. Meanwhile, a customer could generate an invoice, and within each invoice, there's line items. So some invoices could have just one song ordered, and some invoices could have like 20 songs ordered. And so each line item is stored in an invoice line, and the invoice line would contain information about basically each track. All right, and I think there's also playlists. Customers each are also given assigned a customer service representative under employee, and that information is in there. And there's all kinds of stuff keeping track of this. So this is the fictional database that we are imagining here. Okay, so let's go ahead and just try some of the most basic stuff. All right, so first of all, SQL is generally not case sensitive, and the convention, however, is to put your commands in all caps, and then you leave your column names and your variable names basically in the same case as they appear in the table. So in your tables, they might be lowercase, they might be title case, they might be something else. That's kind of convention. Again, it's not case sensitive, so you could leave your select statement as lowercase and things like that, but just for kind of readability, and the convention is you write select in all caps and stuff like that. When you reach the end of your query, we often put in a semicolon. It's not required. You won't get an error if you don't include it, but it's generally recommended to use. Okay, and so your most basic statement will be something like, if you want to look at a table, you're going to do select star from, and then you give it the table name. Okay, so you can select individual column names. So kind of like I'm just drawing a blank on dplyr, but on dplyr it's called select, right? Yeah. So you select column names. Same kind of key thing here. You select column names here, and then if you want to select all of them, you just do select star, and then from will be the name of the table. So, for example, here we will select the basically all the columns from the album table. Okay. Now this is how using the database engine and running our commands will go. First, we have to create a connection. So this is technically how it goes. Is we do engine.connect, we create a connection. Within that connection, we execute a query. And this is our entire SQL query that we are sending over. Select star from album, semicolon. Okay, we put that in quotes. And then we say execute that command from with the connection. That's going to return the results. And technically, you have to tell SQL to fetch all the results. Okay, you're going to do results.fetchAll, and then to kind of organize this, we're going to throw it into a data frame. So we're going to do pandas.dataframe fetch all results. Okay, and then you close the connection. And then here, I'm going to just print off the first 10 rows that it returned. Okay, and so we get so there's only really one thing that we see. This is the album title, and so these are just these are the titles of the album. For those about to rock, we salute you. Balls to the wall, restless and wild, let there be rock. And meanwhile, over here, this is the album ID column, and so this is like album number 1, album number 2, album number 3, and over here we have the artist ID. Okay, and so let there be rock, and for those about to rock, we salute you. Both were produced by artist number 1. Okay, balls to the wall, restless and wild are produced by artist number 2. Jagged Little Pill is from artist number 4. Anybody recognize any of these albums? And who? These are like, again, this database was created probably 15 years ago or so. So this is just what we have. Okay. And anyway, so this is kind of the work that we've written out. Before I forget, let me give you your first view quiz answer. Today's first view quiz answer is C. C as in cat. C as in cat. All right. Okay. So this is kind of a pain. This is kind of a pain. And so there's much easier ways to execute queries. Okay. So one thing that's a little bit less of a pain is you could write, basically you can use the with statement and have it run this way. So here the Sql query is we're going to select the column's first name and last name and the title from the employee table. Okay, and it's I would say it's fairly common convention to start each line, each kind of keyword gets its own line, and sometimes you'll even see it like select. And then on the next line, it'll be first name, last name, title, and then from on the next line, and then on its own line, employee. So you might see this query spread across four lines or something. This is just a text string. Okay, this is just a text string that in Python you can have text strings that span multiple lines by enclosing them in triple quotes. Okay, so here I'm just putting the Sql command inside triple quotes. So I have this thing, and what this thing does, what Sql Alchemy does, is it just passes the text string to kind of it interprets it then. All right, so it just takes that text string and interprets it, understands it as a Sql command, and then it fetches the information. All right, and so what we can do here is, rather than having to open and close the connection, we can do engine.connect, and this will open the connection and then close it when it finishes all of these lines. And now we can do connection.execute command, fetch all the results, throw it into a data frame, and then here I'm going to assign the results keys, okay, which kind of come back in as basically like a list. It's a view object, technically, a view object, and we're going to assign it to the titles of our the column headings of our employees table. Okay, so we see there's Andrew Adams, the general manager, and Nancy Edwards, the sales manager, Jane Peacock, our sales support agent, etc., etc. Okay, and so we can print this out. So this is another way to execute our commands. Okay, even easier, is we could use Panda's functionality called read Sql Query, and this is pretty much this is the command I'm going to be using pretty much from here on out. Is I'm going to be establishing. I'm going to just use Panda's read _Sql _query, which is a really nice feature. Once you have your engine established, then you can kind of run your commands with your engine. So here I'm taking the same command, which is the same string from earlier. Select first name, last name, title from employee, and then I provide it the engine that I want to have run that query, and we assign it to data frame, and we have it print out the data frame, and we see we get the same thing. And if you don't call print on a data frame, then Jupyter formats your Pandas data frame in kind of I think a nicely formatted thing with a little bit of shading and stuff. Okay, so this is how I'm going to be executing my Sql queries. But again, you can kind of you can execute them kind of manually, the old-fashioned way. Yeah.
Sorry, what's engine?
What's an engine? So it's a little bit of a strange thing, but it's when you are trying to retrieve information from a SQL database, you have to have what's called a connection to the database, and Sql Alchemy kind of calls this the engine that allows us to, I guess, fetch and retrieve results from the database. It's a little bit kind of your traditional connection and it's a little bit weird to think of this as like you'll like open a file, and it'll Python will like read in lines from the file, and then if you want to write out lines to the file, it's all kind of doing it through this connection between Python that's running and some some file on your hard drive. SQL has it's a little bit it's almost like you're sending instructions to kind of like a separate entity, and you have to kind of like pass a message. And then they'll send everything back to you. So you don't really get direct access to read and write to a file like you might with a text document. And so so that's why we have to kind of learn this SQL query language, SQL structured query language, and we have to kind of learn how to communicate to this thing. And then the servers, the SQL servers, basically run all of these commands and return the information that you need. So I don't know. Yeah, engine is so for us, the engine is just we're loading up a connection to this database. That as far as we're concerned with SQLite, the database is contained in one file that exists on our hard drive. So it's almost kind of like this regular connection that we still have to communicate through with this through the SQL language. But generally, when you work for a company, they will have a separate server hidden away somewhere. That's their SQL server, and someone will be in charge of maintaining it. And the only way you can kind of talk to it is via these, these little hooks, and you'll have to. Somebody will give you and say, this is your password and this is your login, and this is the command you need to create that connection. So they'll give you instructions on how to connect to that SQL server, usually with some kind of authentication and things like that. Again, I didn't want to get into the trouble of like setting up a server, because that's a huge headache in of itself. There's so to avoid that, we're just going to download this prepackaged database that I think is complex enough to allow us to do some interesting queries and also allow us to avoid all of the headaches of actually managing a server. So I think that's kind of the biggest hurdle in learning SQL is like, I need a database that I could query, but I don't actually want to learn how to set up the database itself. So, yeah.
Do you normally interact with it like with Python or R, or do you have like a separate path to interact with it?
To interact with the server. So, well, SQLite is designed to be kind of this self-contained thing. Probably a more common, like if you wanted to set up your own server, you'd probably download MySQL or Oracle SQL or something like that, and yes, they have tools where you can interact with it directly. A lot of times you'll get like this command line interface, and you'll have to type out all of your commands to interact with it as well. Yeah. If you look up like setting up a SQL server with MySQL, I think you'll realize it's a huge headache. So generally avoid that. Just download this thing and be content practicing on this little toy database, okay? Okay, there is order by, so that's kind of like sort. So here you can do select these columns from table name, and then you'll order by your columns, and you can say ascending or descending. Okay, so here I'm going to say select all the columns from employee, and we're going to order by birth date. Okay, and so here the youngest employee birth date was born 1973, and then our oldest employee was born 1947. I think this is it. All right, so this is just, again, it looks like it's set up in Canada. Alberta, Canada, and we got all of this stuff, and it's just made up information, right? But here this is just our employees table, but we've sorted by birthday. Okay, you can kind of filter your rows by giving conditions with a where statement. Okay, so so here we're going to say select all of the columns. Same thing from the employee table. So here's the full employee table, and we're going to just select here in our case where employee ID is greater than 6. So we have these employees 6, 7, and 8, and then we say title is equal to IT staff. So if we look at that, it will be these two employees, Robert King, Laura Callahan. That's what we'll have. Okay, employees 7 and 8. Their title is IT staff. We're going to order by birth date. Okay, that's all we have. We don't, however you want to do it. So you could imagine any kind of conditional statement. Notice one thing here is when you do SQL, when you do a comparison operation for equal, you want it to equal something, you just use a single equal sign. Okay. Everything else in Python, when we do a comparison operation, we do double equals. Here we do a single equal sign. I think this is pretty straightforward. Okay. A lot of a SQL database is frequently designed to require joins between tables. It's often called a relational database, is what we will have. And we'll have a bunch of tables, and they will be joined together. And this is to kind of avoid duplication. So for example, rather than storing the artist ID here, where we could run into duplicate spelling mistakes, we're going to have basically just one instance of the artist name, and so we're not going to repeat it in the artist in the album table. So for example, this is just to show you what the album table looks like, and this is what the artist table looks like. Okay, so artist 1 is AC/DC, and artist 2 is Accept, and artist 3 is Aerosmith. And so rather than repeating AC/DC every time I see the number 1, I have just a reference to the number 1. And every time we say look up artist ID 1, we can have SQL retrieve AC/DC. And that way, here I have all caps capital A, capital C, / capital D, capital C. Somebody might have put a space between the C and the / or something like that, right? And if we had spelled AC/DC ever so slightly different for this album than we did this album, and that's not like a unreasonable thing to imagine could happen, right? So somebody might put the dots, like if there's like do you abbreviate UCLA as UCLA, or do you put U.C.L.A. How do you do this? And two people might write them slightly differently, and if you have them written differently and you say group them together or identify unique values, they're going to show up as different entries. And so by kind of just saying, hey, this corresponds to artist number 1, you don't run the risk of having spelling mistakes or spelling differences. Okay, so here we've got artist ID 1, and what we want to do is we want to join the album table with the artist table. Okay, both of these things I'm calling limit 10, and that it kind of acts like head in that you only get the first 10 entries returned. Okay, and this would be kind of the recommendation. If you do want to only look at the first few rows, generally we would recommend limiting your results returned here. And it's often frequently recommended to include a limit, especially if you're not sure if your query is going to work in the first place, because the database might have like, several million records that match your query. And if you tell, if you execute this command, the SQL server, you might tie up resources on the server as it's trying to get all million records, and then you realize, oh, that's not actually what I wanted. So it's often recommended you say, limit 10 or something. You get back a few results, and you say, okay, this looks like what I want. Then you can say, all right, give me 1,000, give me 1,000,000 of these things. So anyway, we're going to join these two things together. So this is what a join statement looks like. Is we're going to say select star from, and we're going to say album interjoined with artist. Okay, we're going to join the album table with the artist table. Okay, and then the way we're going to join it is we're going to match up the artist ID in the album table with the artist ID from the artist table. Okay, there's several different kinds of joins. There's the left join, right join, and the inner join. The inner join is, it's only going to include entries where the entry exists in both tables. Okay. And so if for whatever reason this row was missing, if this row didn't exist, we wouldn't see any of these rows here. Okay. So here we're going to say match the artist ID from the album table. So for those about to rock, we salute you. This has artist ID 1, and then we're going to match it to artist ID 1 over in the artist table, and that's AC/DC. Okay, and so we can say, all right, select all of these things, and now we see, okay, for those about to rock, we salute you, AC/DC, balls to the wall, accept, restless and wild, accept, let there be rock, AC/DC, big ones from Aerosmith, Jagged Little Pill from Alanis Morissette, so on and so forth. Okay? Is that all right? This join business. All right. Let me give you your second view quiz answer. Second view quiz answer is D. D as in dog. D as in dog. Okay? All right. Now, we can take these things. So we have title and name. We've got album ID, artist ID, artist ID. What we can do is we can rename columns using as. All right. So we can take title and we'll rename it as, quote, album title. Okay. And then we could take the name, this column name, and we'll rename it as artist name. Okay. And again, we've got from album and dot and dot. And so even though we're no longer selecting these columns, it's still using these columns to join them together. So I got artist ID matched with artist ID. Album artist ID gets matched with artist.artist ID. It's still matching that, and we get this table resulting here. Okay. Wait, I just gave you the answer, right? For the second answer, D as in dog. Okay. All right. So we can do have our queries group information, records together to allow us to calculate summary values. Okay. So for example, we can call count. We can call sum, we can call average. Average will calculate the mean. I have to look up what some of these other ones are. Okay, so here this looks, the commands just keep growing, but here we're going to select artist.artist ID. We're going to calculate the ask for the name column. And then we've got count the album ID as album count, average the album ID. Now that's a silly thing to do, and sum the album ID. Okay, again, averaging and summing ID numbers is a silly thing to do, but I'm just kind of doing it as a demonstration of what these things can do. Okay, and again, here we are joining the album table with the artist table. Okay, and then we're going to run a group by statement. We're going to group them together by artist ID. So again, if I go back a table, right, we can see, AC/DC appears twice, except appears twice. So far, Aerosmith appears once and Alanis Morissette appears once. But here now we are going to group them, and we can say how many albums do they have? And it says, okay, AC/DC has 2 albums, and Accept has 2 albums, and Aerosmith has 1, and Alanis Morissette has 1, and so on and so forth, okay? And Audioslave has 3 albums, and again, it's silly. It's kind of a nonsense query to ask, what's the average album ID, or what is the sum of the album IDs? But here we can do this, and so we can see for AC/DC, the sum of those 2 album IDs is 5, and the average would be 2.5. And also for Accept, the sum is 5, and the average is 2.5. And so just to kind of show you what we have, here is just the album table. We can see if I sort by artist ID, we could see, okay, for AC/DC, their album IDs were 1 and 4, which add up to 5. For Accept, the album IDs are 2 and 3, which also add up to 5, and so on and so forth. And so that's kind of, it's grouping those records together and providing the summary that we've requested. All right. Okay. Do we feel like we can read this? Okay. The Sql command and make sense of it. Okay. So we're just kind of adding vocabulary and building up our commands and complexity. Okay, if you want, so we have a where statement, and then if you want to kind of filter your results based on a summary value, then you have to use the condition having. So here we're going to select the artist ID, the name, the count, all right, the album count, and here, now I want to say, give me the artists who have more than 8 albums, and so I can't use. So back here I have like a where statement. Where did it go? Okay, we have where statements, which we can use to set conditions on individual lines. But here we don't want to use where. Where is used to select from the rows. Here we're going to. I ran out of battery here. What we want to do is we're going to call having. Okay. So here again, we're just kind of selecting the same columns, joining the table on the same type of thing, and now we're going to say having album count greater than 8. And so this filters out the resulting summary table just to those with these conditions here. Okay, and so our commands just get more and more complex, but hopefully it's okay so far. I think we're gonna run out of time. We'll continue this on Wednesday as well. Okay, there's other things you can do. You can just say, hey, you know what? I want to do some numeric calculations, right? So if you want to do some numeric calculations with some of your columns, you can do that. So here I'm just taking artist ID, and I'm just going to take that number and multiply it by 2, which is a completely silly thing to do, but this is how you would do it, okay? And so you can do kind of your calculations here and whatnot. I think, yeah, I'll come back and I'll do some more. All right, I don't think I want to get into these queries yet. So these ones get fairly complex. So I'm having previews of what the tables look like, so that later on when I do queries, we could see how they're all linking up. Okay, why don't we just end a little bit early today, and let me give you your last view quiz answer, which is the letter B, B as in bear, B as in bear, and then I will we'll cover more SQL examples on Wednesday as well. Do a few more of these types of examples. But yeah, go ahead and try to pull the changes from today's, from GitHub, and you can see if you can run the queries that appear in this Jupyter notebook to just kind of make sure that you can connect to the SQLite database and execute a few practice some of these queries here. Okay, we'll end here. Have a good rest of your day. We'll see you on Wednesday.